Welcome back. After doing a 2-star alignment or 3-star alignment or any type of alignment of the telescope won't be perfectly aligned with exactly what the sky is. It'll be off by a small fraction of a degree. So there's 2 techniques for actually getting onto the field and making sure that you're recording the right part of the sky for doing an occultation event. We have a previous video that you can check out in which Matthew and I work on a thing called the star training set, where we're actually training ourselves by going from star to star to star to star to target and figuring out like how is the alignment pointing. But there's actually another technique you can also use called precise go-to that Diana and I are going to do right now and show you how to use that alternative to getting onto the right part of the sky. So to do precise go-to, first you want to have the hand paddle. And what does it say right now?
CP ready.
Yeah, so CPC ready, that's the standard prompt that you get when the CPC is ready to go. And so what you'll do is hit the menu button, which is number 7, I believe. And then you can use the 6 button or the 9 button to go up and down to the following menu, which is called precise go-to. Awesome. So when you hit precise go-to, it'll then ask things like, what is that, go-to type. So it's right now saying go-to type database, where we are actually going to enter some right ascension and declination values. So you want to use the arrow buttons to get to the RA-DEC setting. So it says data type RA-DEC. At this point, you can enter the actual right ascension and declination of the target star that is being occulted. And so on our star training set, that's the very last star in this list of stars. So I'm going to have Diana type in the following right ascension and declination coordinates. So RA is 03, 30, 11.4. And you can hit enter. And then at this point, there's either a plus or a minus. You can use the arrow keys to go up or down to plus and minus. But we want to select plus, and you'll hit enter. And then the declination is 46, 38, 31. All right, it says now searching, and there's a percentage bar going through. The computer inside the telescope just looked through its database to see what are the brightest stars nearby to this target that it knows we will be able to recognize because they're obviously bright stars. And it has chosen MIRFAC as the first option. What happens if you press the arrow buttons? So it gives us a second choice of Algol, a third choice of Menkib, fourth choice Alik. So it gives you a number of choices that you can use. It also tells you how far away the star is, the distance in degrees from the target. Typically the first one is the closest, so let's go back to that first one. This is just using the arrow keys. And how far is MIRFAC from the target?
3 degrees.
Okay, 3 degrees, 22 minutes. Okay. At this point, we are going to select MIRFAC and press enter. The telescope is trying to point itself to this bright star called MIRFAC. And we will look on the screen here to see where MIRFAC is when the telescope points to where it thinks MIRFAC is. You can see stars going through the screen, coming down. Somewhere in here we should expect to see a very bright star. Look, there it is, there's a bright star. And notice that it's not directly centered in the camera because our alignment wasn't completely perfect. What does it say on the screen?
Center MIRFAC.
Okay, so it's asking us to now center MIRFAC using the hand paddle. So Diana can use the left arrows and right arrows to center MIRFAC into that part of the camera field of view. So she's moving it over. She'll have to move it over and up to get it into the center. You're centering it perfectly in the camera field. And as you're doing this, the telescope is keeping track of the number of position moves you've done, so that when it next goes to the target star, it will use that same offset to center the field of view that we care about. And what does it say on the hand paddle? So it says enter. And so after we've centered MIRFAC, you press enter. Now it's using that offset to point to the actual coordinates that we gave it, this target star coordinates. And so it should now center in the middle of the camera where the target actually is. Now this target star, while MIRFAC was a star that's roughly second magnitude, the target star we're looking at is actually 16th magnitude, which is 4 14 orders of magnitude or 1,000,000 times fainter. And so just like in the previous video, we'll want to increase the sense up by pressing down the camera button on the menu and changing the sense up from ×8 to ×128, which is the most sensitive we can make the camera. So you go down and up and over. This is actually going to integrate 128 frames, with each frame being a 1/60th of a second, so these will make 2-second exposures. In a couple of seconds, this will become brighter and brighter and brighter. And now what we want to do, just like with the last video, is we want to come over here and see if we can find the same pattern of stars as on the star training set, where we have 5 stars here, which are these 5 stars here, and we're looking for this pattern of 5 stars that match that. So do you see that anywhere, Diana?
Yeah, I think these stars here correspond to these ones.
Right, exactly. So these 5 stars correspond to those 5 stars, and there's an arrow here that shows us that the target star we care about is between those 2 stars. And so it's like somewhere right in there, and again, it's a really faint star because it's 16th magnitude. But if you get to this point where you're actually able to look at the stars and confirm that the patterns there exactly match the patterns here, you know you're in the right place, you know you're on target, and that you are ready to observe the occultation event. Any questions, Diana?
I don't think so. Ready to observe.
Ready to observe. So this is called the precise go-to technique. The previous technique we call star training, because we're training ourselves that the offset was over here and we needed to manually move the telescope over. This kind of bypasses that, and the computer inside of the telescope keeps track of that for us and automatically does the correction when we go to the target star. You may ask yourself, which one should you use? And it really depends upon your preference. Mark's preference is to start with precise go-to, because if you get it, you know you got it, and if you didn't get it, you always have a backup, which is the go to REDEC, the previous videos option. And so you haven't lost that much time. You're already in the right area of the field of view of the telescope, and so you can go and see if precise go-to works. If it's good, you're ready to go, just like that. If not, you can then go to the other technique, which is the star training set, and you know that that will work and just take a couple extra minutes. Because I like to have more students have you guys be able to use the telescope more and point to more things and become more comfortable with the telescope, I typically train folks to basically be able to use the other video, the star training set, to get to the right, to get to the star field, and then use this as just something that you know you can use if you ever want to use it. So that was probably more words and more confusion than you needed, but hopefully this helps explain how precise go-to works and how it's essentially the same as star training, but the computer's doing the thinking instead of us doing the thinking. Think on, rock and roll. We're ready to record. That's the next video. We're now going to record this star field as though it was an occultation event. Thanks a lot.